Welcome to a new journey of knowledge. Today we dive into the fascinating world of experimental study designs. Just as an architect requires a blueprint to construct a building, scientists need a study design to conduct their research. Experimental study designs serve as these blueprints, guiding researchers on how to systematically gather and analyze data. Let's imagine the world of scientific research as a vast ocean. It's filled with countless variables, all interacting with each other in complex and often unpredictable ways. Experimental study designs are like the compass and map that help researchers navigate this ocean, zeroing in on specific variables and understanding how they influence each other. But why are these study designs so important? Well, they allow researchers to establish cause and effect relationships between variables. They help us understand why certain things occur, how one factor can influence another, and what might happen if we change something. For instance, in the field of medicine, experimental study designs are the backbone of clinical trials. They allow scientists to determine whether a new medication is effective or if a particular treatment method has side effects. Without these designs, we wouldn't be able to develop new drugs or improve existing treatments. In the realm of psychology, experimental study designs help researchers understand how different factors affect human behavior. They can be used to study everything from the impact of stress on mental health to the effects of different teaching methods on student performance. The beauty of experimental study designs is that they can be applied to virtually any field of research, from sociology and economics to environmental science and beyond. They are the tools that allow researchers to cut through the noise and complexity of the real world, isolating specific variables and studying them in a controlled, systematic way. So, are you ready to explore the different types of experimental study designs? Buckle up as we delve deeper into this intriguing subject. To start, let's focus on the basic experimental study design. In any experimental study design, there are three key components that we need to understand: the control group, the treatment group, and the variables. These elements are the building blocks of our experimental structure, and they set the stage for our scientific exploration. First, we have the control group. This group serves as our baseline, our standard of comparison. It's the group that does not receive the treatment or intervention we're studying. By keeping this group under normal conditions, we can see how they behave without the influence of our experiment. This allows us to understand what happens naturally, without any external changes. Next, we have the treatment group. This group is the one that receives the experimental treatment or intervention. It's the group where we implement the changes we want to study. The treatment group is the one we compare to the control group to see what effects our intervention might have. Now let's talk about variables. In the world of experimental study design, we're dealing with two main types of variables: independent and dependent. The independent variable is the one we manipulate or change, like the introduction of a new medication or a new teaching method. It's the cause in our cause and effect relationship. On the other hand, the dependent variable is the one we measure or observe. It's the effect in our cause and effect relationship. This could be something like the recovery rate of patients after introducing a new medication, or the improvement in students' grades after implementing a new teaching method. Together, these components allow us to implement a structured, systematic approach to studying potential cause and effect relationships. By manipulating the independent variable in our treatment group and observing the effects on the dependent variable, we can begin to draw conclusions about the potential impacts of our intervention. With this foundation, we are prepared to venture into the diverse types of experimental study designs. Our first stop in this exploration is the Randomized Controlled Trials. Randomized Controlled Trials, often abbreviated as RCTs, are a type of experimental study design that sits atop the hierarchy of evidence. These trials are lauded for their ability to determine cause and effect relationships and thus are often used in clinical research to test the efficacy of new treatments or interventions. So, how does an RCT work? Well, it all starts with random assignment. Participants are randomly allocated to either the experimental group or the control group. The experimental group receives the treatment or intervention under investigation, while the control group receives a placebo or the standard treatment. By doing this, researchers can compare the outcomes of the two groups and conclude whether the intervention had any effect. Random assignment is a key element of RCTs, and it's what makes them so robust. It helps to balance out any differences between the groups, such as age, gender, or health status. This means that any difference in outcomes between the groups can be attributed to the intervention, and not to some other confounding variable. But like any other study design, RCTs come with their own set of advantages and limitations. On the plus side, they provide high-quality evidence and reduce bias, as the researcher doesn't decide who gets assigned to which group. Additionally, the random assignment helps to balance out confounding variables. On the downside, RCTs can be expensive and time-consuming. They also require a large number of participants to ensure statistical power. Furthermore, ethical considerations can limit the use of RCTs, particularly in situations where withholding treatment from a control group would be unethical. Randomized controlled trials, though powerful, are just one type of experimental study designs. Let's move to another kind. Next in line is the cohort study design. Now let's imagine a group of people, a cohort, that we're interested in studying. This could be anyone from a group of office workers to a population of a small town. The key point here is that they share a common characteristic or experience within a defined period. So what does a cohort study do? It follows this group over time. We start by identifying a group of individuals who are disease-free but exposed to a certain factor. We then compare them with a group of individuals who are also disease-free but not exposed to the factor. The goal is to determine whether the exposure increases the risk of developing the disease. One of the strengths of cohort studies is that they can help clarify the temporal sequence between exposure and disease. In other words, they help us determine which came first, the chicken or the egg, so to speak. They're also great for studying rare exposures like occupational hazards that are difficult to study in other designs. However, cohort studies aren't without their weaknesses. They can be time-consuming and expensive, especially when studying diseases that take a long time to develop. There's also the possibility of losing track of participants over time, which can introduce bias into the study. And then there's the issue of confounding variables. These are factors that are associated with the exposure and affect the risk of developing the disease. If not accounted for, they can skew the results of the study. In essence, the cohort study design is like a long journey. It starts with a group of people, follows them over time, and observes what happens. It's a powerful tool that can help us understand the relationship between an exposure and a disease. The journey doesn't end here. We have more intriguing designs to uncover. Now, we turn our attention to the case control study design. Imagine you're a detective trying to solve a mystery. In this scenario, the mystery is a disease or health condition, and your suspects are various risk factors. This essentially embodies the spirit of a case control study design. In this design, researchers work backwards. They start with individuals who already have the outcome of interest, the cases, and a group of individuals without the outcome, the controls. The goal is to trace back and compare the exposure to potential risk factors between these two groups. Consider it this way. You're investigating a rare disease that suddenly surfaced in your town. You gather a group of affected individuals, your cases, and a group of unaffected individuals, your controls. You then delve into their past, looking for differences in their lifestyles, habits, or exposures that might explain why the cases have the disease and the controls do not. The case control study design shines in its ability to study rare conditions or diseases. Since it starts with the outcome, it's perfect for situations where the disease of interest occurs infrequently. It's also cost-effective and quicker to execute as it doesn't require following individuals over time. But as with any experimental design, it's not without its drawbacks. This design is retrospective, meaning it relies heavily on participants' memories of past exposures, which can sometimes be inaccurate or biased. Additionally, it's not the best design to determine the timeline of exposure and disease onset. Despite these drawbacks, the case control study design remains a powerful tool in the researcher's arsenal, particularly when dealing with rare diseases or when time and resources are limited. With that, we have explored another impressive experimental study design, but there's more to come. Our last stop in this journey is the cross-sectional study design. As the name suggests, a cross-sectional study design is like taking a cross-section, or snapshot, of a population at a particular point in time. It's kind of like taking a group photo at a party, but instead of capturing smiles and party hats, we're capturing data. This design is used when researchers want to get a broad overview of a population without the constraints of time. To understand this better, let's imagine a researcher who is interested in studying the prevalence of smartphone usage among teenagers. They would collect data from a sample of teenagers at a specific point in time, asking questions about their current smartphone usage. This snapshot provides a wealth of data that can help researchers understand a phenomenon as it exists in the present moment. One of the main advantages of the cross-sectional study design is its efficiency. It's often less time-consuming and less expensive than other study designs because it involves only one interaction with participants. It also allows researchers to examine multiple variables at once, making it a valuable tool for exploratory research. However, like every experimental design, cross-sectional studies have their limitations. The most significant is the inability to establish causality. Since data is collected at a single point in time, we can't determine whether one variable causes changes in another. Going back to our smartphone usage example, if we find a correlation between screen time and sleep quality, we can't conclude that using smartphones causes poor sleep. It could be that poor sleep leads to increased screen time, or an entirely different factor could be influencing both. Another limitation is the potential for recall bias. Since participants are asked about their current status or behaviors, their responses may not be entirely accurate due to memory errors or intentional misreporting. With the cross-sectional study design, we conclude our exploration of experimental study designs. Remember, each design has its own strengths and weaknesses, and the best choice depends on the research question at hand. This journey through experimental study designs might have been a whirlwind, but hopefully, it's left you with a clearer understanding of the landscape. What an enlightening journey it has been, exploring the diverse world of experimental study designs. Let's recap what we've unveiled in this journey. We started with an introduction to experimental study designs, which serve as the backbone of scientific research. They provide a systematic approach to investigate causal relationships and to test hypotheses, making them indispensable in the world of science. Next, we delved into the basic experimental study design, which is like the mother of all designs. It is the simplest form, where researchers control and manipulate variables to observe the effect on a subject. This design forms the basis for all other types, underlining its significance. Then, we ventured into the realm of randomized controlled trials, or RCTs. These are the gold standard in experimental research, providing the highest level of evidence. With their unique feature of random assignment, they minimize bias and ensure that any observed effects are due to the intervention and not confounding factors. Our journey continued with the cohort study design. This design is observational in nature, where researchers follow a group over time to see how certain factors affect the outcomes. Cohort studies are particularly useful for studying diseases and their risk factors, providing valuable insights into cause and effect relationships. Then, we unraveled the case control study design, another observational design, but this one starts with the outcome and works backward to find the exposure. It's like a detective story, where the researcher is the detective, seeking out the cause of an event that has already occurred. Lastly, we discovered the cross-sectional study design. As a snapshot of a population at a particular point in time, it's like a scientific selfie. It's a quick and cost-effective way to gather information about a population, making it ideal for public health research and policy development. Each of these designs has its unique strengths and applications, making them invaluable tools in the quest for knowledge. They help researchers to answer complex questions, test hypotheses, and provide evidence to inform policy and practice. Their importance in scientific research cannot be overstated. As we conclude, remember that the choice of study design depends on the research question, the resources available, and the nature of the variables involved. It's like choosing the right tool for the job. And as with any tool, it's important to use it correctly to get accurate and reliable results. Thank you for joining us on this journey. Don't forget to subscribe for more enlightening videos like this, and you can find the script in the description below. Until next time, keep exploring.